That's good. Here is Melinda, and this is her discipline lesson, junior year. Melinda, what is your state standard, please?
It's kind of long. Electron energy levels consist of sublevels, S, P, D, and F, each with a characteristic number and shape of orbitals. The shapes of D and F orbitals will not be assessed in high school. Orbital diagrams and electron configurations can be constructed to show the location of electrons in an atom using established rules. However, the names of these rules will not be assessed. Valence electrons are responsible for most of the chemical properties of elements.
Whew.
In this course, electron configurations, extended and noble gas notation, and orbital diagrams can be shown for any element in the first 3 periods.
Now, can we have your personal learning goals? Good Lord, that's long.
My goals are, I have 3. 1, my students will be able to participate with a partner and solve electron configurations to 95% accuracy. The student will be able to draw on a whiteboard the correct configuration for an element with a group to 95% accuracy. And the last one, the student will be able to complete an independent worksheet to 100% accuracy.
Awesome. They're all yours, my love.
All right, good morning, guys. You see that your question of the day is posted on the board. Can I get started with that on your loose piece of paper? That'd be great. If you have any questions, go ahead and let me know. Today's March 1st. Are you guys able to see it back here? Are you guys over here? Yes. You can look at your electron configuration table that I passed out earlier. Maybe about 2 more minutes. You guys all right over here? Once you're done, if we can have all eyes up here, that'd be great. Do I have all eyes? Alright, so if someone could raise their hand and tell me what they think an electron configuration is. Anyone? Nope.
I said something to do with like atoms and how they're made, like bonds.
You're on the right track. An electron configuration is, and also if you would like to write down the right answers, this would be very beneficial later. What do you think an electron configuration is? It's a numeric representation of its electron orbitals. We'll go more in depth about that in the notes. So right now it's probably a little fuzzy. Yes, Paige? Yes. An electron configuration is a numeric representation of its electron orbitals. Yes, Kenneth? The electron
outer
rings. Yes. Does everyone have that down? Alright. So can someone give me the first noble gas? Ashley. Helium, correct. The second noble gas, Claudia. Yes. The third noble gas? What was that, Becca? Yes, it is argon. And fourth noble gas? Pushing it here. Fourth, Ashley C. Crifton? Yes. And if you need help spelling any of these, you can go ahead and ask me. And the last one. Set. Yes. Does everyone have those down? Nope.
What was the second one?
The second one was neon. Any questions on the question of the day? No? Crystal clear? Okay. Alright, so on your desks, you're going to notice that I passed out a packet of notes. Go ahead and pull those out.
Miss Thomas, if you want to make those bigger, the rotator dial will magnify those. It's up to you.
Alright, can everyone see that in the back? If not, you can scoot to the front. Yes, ma'am?
Turn the front lights on.
Yeah.
Thanks.
Whoa. There's a button.
There you go. It was adjusted.
Just takes
Oh,
a
it
second
adjusted.
to adjust.
Okay. Alright. So, can someone read the first bullet point of energy levels? Set.
Energy level of electrons within an atom are represented by quantum numbers.
Seth, can you swallow your food, please, and then give me the answer? Alright. Can someone else give me the answer while Seth is digesting? Keely.
The energy levels of electrons within an atom are represented by quantum numbers.
Good job. Alright, so a principal quantum number is going to represent the principal energy level. So, for example, magnesium, if you look at your electron configuration table, can someone tell me the energy level you think it would be in?
It's okay, Seth. I know the high link.
Claudia? It is. It is going to be in 3. Alright. And what do you think, why do you think that it is in the third period level? What does this mean that the element has? Kaylee?
3 outer orbitals.
What does that mean? Go more in depth.
The 3 outer rings. So like the first 3 and then there's like 2 things.
So that means it has 3 energy levels?
Yes, that is what I'm getting at.
Seth, I'm gonna have to ask you to put your food away, please. Tuck it in your backpack, save it for lunch a little bit, alright? Alright. So the total number of sublevels for each principal energy level is equal to the what? Does anybody have any idea? No? Alright. It is gonna be the number of principal energy levels. And this all may seem confusing right now, but it'll make sense once we get to our activity. And so, the first principal energy has 1 sublevel. The second principal energy has 2 sublevels. This means it has a second outer ring. So a sublevel is a ring on an element. Does that make sense? Alright, I probably worded that weird. If you have questions, go ahead. So the first sublevel is going to be the S sublevel. the last one, whenever you get to F, it becomes an orbital. So it'll be an F orbital.
How come they don't go in alphabetical order?
I'm not too sure, but we can look that up later as well. So can someone read the bullet point for orbitals? So,
Each sublevel may consist of one or more orbitals, with each orbital having a different facial orientation.
alright, good job. So with an orbital, an electron occupies an orbital. Does anybody know how many electrons an orbital can hold? 8. 8. That is for showing the electrons, but in an orbital they can hold no more than 2. Alright, can someone read the example? Emma?
First principle energy level has a median point group that is
Alright, so since the second principal energy level has 4 orbitals, the 1s orbital and the 3p orbitals. If you look at your electron configuration tables, that'll clarify that for you. Did I skip a point? I did skip a point. It's equal to... Thank you, Claudia. So 2 squared is what? 4. Alright. So each principal energy level can hold, how many do you guys think it can hold? 4. It can hold 4, but 4 is a certain number of electrons. So the fill in the blank would be a certain amount of electrons. Alright. So electron configurations of the atoms in order of their atomic numbers starting with hydrogen can build up by adding 1 electron at a time with the following rules. You want to star these rules because they will show up later. So go ahead and start them. Alright. No more than 2 electrons can be in any orbital. And it is very important that you remember that these 2 electrons have opposite spins. Bless you.
You didn't?
In a given sublevel, a second electron is not added until Each orbital in the sublevel contains one electron. Seth, I'm gonna have to ask you to put your food away. This is gonna be the last time I'm gonna ask you before you get into tension. Is that alright? Alright. So with this means you're gonna fill each orbital until all of them have one before you go back. You'll understand when you see it visually, probably. This may seem very confusing. Alright, and whenever you go through these, in an electron configuration, the number of electrons in a sublabel is indicated by a superscript. If you look at the example, the superscript is going to be the numbers above the S's and P's and other variables. So these will be your superscripts. So what would be the electron configuration for phosphorus? If you guys take pull out your electron configuration table that I passed out. Miss up.
Is this how we become attracted to people? Like, is it my electrons that are like, ooh, I need your electrons?
I don't think so, but later on we'll learn about how chemicals bond, and they do need each other.
Because they talk about chemistry between people, so I was wondering if my electrons had it going on or something.
I don't think so, Miss Up.
Oh, okay.
Alright. So
It'd be
the
easier to
electron
find them.
configuration for phosphorus would be 1s2, 2s2.
Samus, can you move that up? It's really
Oh,
hard
yeah.
though.
Can I like move your stuff? Alright.
You can move whatever you guys want. You must educate the children.
Is that a 5 or an S?
That's an S. Alright. So I'm going to show you how I did this.
Miss Thomas,
Yes.
are you lesbian?
No, I am not. Let's stay on track, alright?
I just think it's funny that you keep calling on girls. Like, you hit on them?
No, I'm not. No. Do we need to have a conversation after class?
No, we really don't. I was just wondering why you always call on the girls, but won't call on us. Just think you're hitting on them.
Alright, how about this, Noah? How did I get phosphorus? How did I get the first energy level of phosphorus?
I think it was when you went on that date with that guy and he ended up staying you up.
No, we're not gonna have this conversation right now in the middle of class. You're distracting. Be honest.
I don't know. I just think it's funny.
Noah?
Is that why you're hitting on the girls? It's like,
Noah, I'm gonna need you to go in my office.
I'm just asking questions. Like, this is boring, so I just wanted to know if you were like lesbian.
Noah, I am not lesbian. We have other activities we have to get to, so I'm gonna need you to step in my office, please.
I don't know, Miss T. I was just wondering. Like,
Noah O'Shea.
she did call on you. She called on you guys too. I just think it's funny.
Noah O'Shea,
Yeah.
step in my office now.
That's. Is that
No,
what happened?
let's have a word in my office, alright? With your flux, can you go ahead and look and try to figure out how we discovered phosphorus's electron configuration? Noah, we need to take a step in my office right now. Let's go.
Whatever.
I think I can stand you up and get mad again.
I'm going to call Mr. Payton here, and we're going to have a little sit down and have a conversation.
I'm just wondering, it's just like you always call on the girls, and it's Seth and I are just out there, and you're always hitting on them. I just want to know if you're lesbian.
Noah, there are two gentlemen in my class, so it is kind of hard to always pick on two gentlemen. Then they will think that I'm flirting with you. So I do not feel like I need to explain myself to you. So we're gonna have a seat in here until Mr. Pate comes, and that's the end of the story. All right?
But what if we have the right answer and the girls don't? That's what happens most of the time. You're just always hitting on the girls and calling on them. I was just wondering if you were. We don't need to be here. I was just asking, you know.
No, we're gonna have a seat in here. All right? We're just gonna. That way, there are no more issues. All right?
Yeah, I guess.
Thank you. Did we solve how to get the electron configuration of phosphorus yet?
I'm sorry.
Alright. Alright, so to get to phosphorus, we have to go across to go 1s1, 1s2. And that's the first sublevel. Then to go to the next sublevel, we have to go down to 2s. And to get to across again, we have to go to 2s1, 2s2. Then we go across and we're at 2p. So then we have to go across all 6, so then it's 2p6. Then we go to 3s, and to get across we have to go to 1 and 2, so it'll be 3s2. And then finally we're at phosphorus's sublevel. So phosphorus, which one is phosphorus? Can someone give me a number? The third one? Alright, Claudia. So then what does that mean?
You go again, call on Claudia.
3p3? Alright, there you go.
When I was in New Zealand, they took us to this cave, and the phosphorus glowed, and they called it the glowworm cave because the glowworms would absorb phosphorus out of the ground, and then when you went into the cave, they would like literally glow. And then they put in phosphorus like at night.
Maybe we'll look that up at the end of class.
It's really cool. It's in New Zealand.
Alright. So you can think of it as stairs. So you have to go from 1s2 to the next staircase to get all the way up to P, phosphorus. Does everyone understand that? Yes, Keith?
I'm sorry. Can we go over it one more time?
Alright. So, if this is a staircase, to get all the way down to P,
Yes.
we have to climb the stairs, correct?
Yes.
Alright, so we have to go from 1s2 to the next staircase.
Well, that makes sense.
And then 2s2 is the next staircase. So then we have to go to this staircase. And it's 2p6. So we're climbing all of these stairs to 6. Then we run out of stairs, so we have to go to the next one, which is 3s2.
Okay. Yes.
Do you understand?
I understand that. Now.
Alright.
Okay.
Do we have any questions? No? Alright. Alright. Noble gas notation. So this, for your question of the day, I had you list the first 5 noble gases. These are very important because you can use these to not have to do all of the writing that we just did. So, for boron, you see how the electron configuration is 1s2, 2s2, 2p1. Instead, you can use the first noble gas that you passed before, how do I want to word this? You can use the noble gas that you last passed
On the stairs.
on the stairs.
Okay.
So, instead of it, what is this? Oh, sorry. Alright. So, since helium is the last noble gas you pass before you get to boron, you use helium. But say we're doing phosphorus again. Instead of writing 1s2, 2s2, 2p6, we could write neon, 3s2, 3p3. Saves you the writing. Alright, so let's practice that because that could be a little confusing. So we're going to do oxygen. Alright, so can someone give me the electron configuration for oxygen? So since oxygen is in 2p, which staircase do we have to pass first? Seth? Which staircase do we have to pass first?
Wow, I'm going on the
Yes. So it'll be 1s, 2. Since we have to visit both 1s's.
Okay.
So then the next staircase we'd have to pass would be, it would be, yes, 2s, 2. So since we're at the sublevel of oxygen, it would be 2p4.
Hi. I'm so glad I don't do this for a living.
But if we use our noble gas notation, which would be the last noble gas we passed? Neon. No? Helium. So you put it in square brackets, and then you continue. So then you just skip that whole staircase. Yes, Paige? So you know that's noble gas. Right, we're going to do one a little bit more difficult. And then you'll see why you want to use the noble gas notation.
You say yeah.
Yes. Alright, so let's do calcium. Go ahead and try calcium's electron configuration. Hi, Mr. Pete. I have a student who is not wanting to cooperate in the lesson, is making inappropriate comments.
Is he on his way yet? He don't want to stood you up.
Noah O'Shea. These are inappropriate. Noah.
Yeah, there's 2 guys in the class, but you always flirt with the girls. And like, it's just kind of weird. And like, I don't know if the girls feel uncomfortable. So it makes me feel uncomfortable. Like, did a guy stand you up? Or like, is that why you're like this?
Noah.
Did you have a date at the movies?
Noah.
And the guy just didn't show up?
No, I'm right, eye contact right here, okay? This, I have a class of 9 girls with 2 boys.
Mhm.
I cannot constantly pick on the 2 boys with leaving the girls out. That's an uneven ratio, okay? Do you understand that? So I cannot constantly be picking on boys. So it may seem as though I am constantly picking on the girls, but that's my only option other than you 2. Alright, so that's the end of this conversation right now, because it's inappropriate and I don't feel as though I need to have this conversation with my student. So that's what's going to happen, and you're going to sit in this class, you're going to sit in this office right now, and we're going to stay quiet right now until Mr. Pate gets here, okay?
Why didn't you get a classroom with like more boys though? Why can't we
This
have,
is what I
like,
was assigned.
Jordan and Kyle come in here? That would be 4 boys to 9 girls. That wouldn't be as bad.
This is what I was assigned, because this is a 10th grade honors chemistry class.
I mean, yeah. I was
So
just wondering,
you-
like,
You need to stay in here and stay quiet, alright? We are trying to learn about electron configurations in there, alright?
I wouldn't know because I'm in here.
Well, you put yourself in here, Noah.
No, I didn't. I was just asking questions.
They're inappropriate questions that do not need to be talked about in class, right?
Yeah.
Alright, thank you.
Mr. Page.